Hello everyone. In this video, we will explore an interesting topic, generating outlines from laser scanning. I hope you find this lesson interesting and useful. Let's get started. At the beginning of our work, we need to import a point cloud into the program. For convenience, let's open the topographic file template, which can be found in the Templates folder. To import the point cloud, go to the Point Clouds tab, and in the group of the same name, select the Import command. Confirm the visual style change. Open our file. In the Point Cloud Import Settings window, set the thinning value to 10 and specify meters in the Import Settings section. Click OK to start importing the point cloud into the program. Using the View Mode command, set the coloring field to elevation. Leave the ranges unchanged. As we can see, the cloud is colored by elevation. Let's save our document. Now let's classify the ground and vegetation points. To do this, go to the 3DScan tab, and in the classification group, use the ground command. This command changes the class attribute of the point cloud and moves the points to the appropriate classes for easier further processing. At the moment, our cloud does not have a class attribute, so we cannot use this command yet. This message can be seen in the command line. For further work, it is necessary to create an attribute for the point cloud. In the Point Clouds tab, in the Information group, use the Point Clouds Info command. This dialog box contains various information about the point cloud. But in this case, we do not need it. We only need to click on the plus icon. In the pop-up window, check the box next to the class line and the Create Layer line. This command will create the class attribute and a layer for this class, which will contain unclassified points. Now, let's use the ground command. Set the following parameters in the fields on the left panel. Cell size 0.5, maximum window size 10, terrain angle 77, iteration angle 70, maximum distance 0.2. Next, adjust the height parameter for classifying high vegetation, setting it to 30. Leave the other parameters unchanged and apply the settings by selecting Yes. Using the View Mode command, change the display of our point cloud by setting the coloring field to code. As we can see, the view is changed according to the display method. We can disable or enable individual layers using the Layer Manager panel. Let's activate it using the Layer Squick command via dynamic input. For example, disable the vegetation layers. Let's sequentially return all vegetation layers, starting with low vegetation, and observe how the point cloud changes. After reviewing how ground and vegetation classification works, let's ensure that the ground class points are correctly recognized. The verification of the Earth command can help with this. Activate it, and a second view screen will appear along with the Ground Verify panel. Let's move the panel that appears on the left a little bit to make it more convenient. This panel contains various settings that we can change and make the verification process more comfortable. Let's leave all the settings in it at default. For the left viewport, let's set Shaded Display Style. When zooming in closer to the surface, you can see every depth and up of the ground. End this command by closing the Ground Verify panel. Now let's create a tin surface based on the point cloud. To do this, on the 3DScan tab and in the Meshes group, use the Creating of Tin command. Set the following values in the fields on the left panel: Result Type Values, Subdivision Mesh, Break for Optimization, No, Use Class, Ground, Create Layer, Yes. Apply the parameters and wait for the triangulation network to be created. Let's use the Layer Manager panel to hide the ground and vegetation layers. Now we can see our created triangulation network. Then, in the same group, select the Simplifying the Mesh command. Using the slider in the % field, set the value to 75, leaving the other parameters unchanged. Confirm the parameter input by selecting Yes. Our network has been simplified, though the difference isn't very noticeable. If this parameter is reduced further, the network will be simplified more significantly, and the change will become more apparent. Now, let's use the functionality provided by the Topoplan module to prepare a geodetic base. Go to the Topoplan tab, and in the Settings group, set the Toposcale value to 1/500. Let's create contour lines. To do this, in the Relief group, select the Create Contour Lines command. On the left, you'll see the parameters that appear. First, set the value in the Contour Smoothing field to Yes. In the newly appeared Smoothness Level field, set the value to 70. And in the Avoid Contours Crossing field, select Yes. Now, configure the contour line settings. Let's disable the creation of auxiliary contour lines and supplementary contour lines by setting the value in the Draw fields to No. In the Settings group for intermediate contour lines, we won't change anything, but in the group for index contour lines, we'll change the contour line color. For example, select this one. Set the line weight to 0.5. Confirm the parameters. Let's hide our tin surface using the Layer Manager panel. As we can see, contour lines have appeared, describing our terrain. Now, let's proceed to add bergstriches and height labels for the contour lines. Let's examine a small part of our drawing at the top right corner. Using the Units command, change the number of decimal places. For elements with the length parameter, set Precision to 0.0. Click OK. Now, in the Relief group, activate the Contour Lines Label command. Set the Text Height field to a value of 1 and confirm the parameters. Add the height labels. Now, in the same group, activate the bergstrich command. Similarly, without changing the parameters in the panel on the left, confirm them by selecting Yes. Specify the positions of the bergstriches on the drawing. Now our drawing is ready for printing. This concludes our lesson. Thanks for your attention. See you in the next videos.